Welcome everyone, my name is Mr. McGregor and today we're going to look at Newton's second law. By the end of this video, you'll be able to calculate force using the equation F net equals mass times acceleration, and you'll be able to rearrange that equation to solve for an unknown variable. I'm going to start by recapping some content from the previous video. You may recall this was Newton's first law. Things like to keep on doing what they're already doing unless acted on by an unbalanced or net force. This means that if the forces are balanced, there will be zero acceleration or no change in speed. It's going to keep on doing what it's already doing, be that sitting still or be that moving at a constant speed. But if the forces are unbalanced, then there will be a change in acceleration. So it will change its speed. It will speed up or it will slow down, or it will change direction. Which is quite simply this equation here, that the net force is equal to the mass multiplied by the acceleration, where F net is the net force acting on the object measured in newtons, m is the mass of the object in kilograms, and a is the acceleration of the object in meters per second. All of these terms we've come across before. Once again, we can use our triangle in this form to help us rearrange this equation. So let's start with an example. Let's pick a balanced force example. Here we see someone is parachuting down from a plane, and let's say he has got a gravitational force or a weight force of 620 newtons, and the drag force is equal to that at 620 newtons also. This means if we calculate the net force, 620 minus 620 gives us 0 newtons. That is to say that the forces are balanced. If we use our triangle to find the acceleration, we use the equation acceleration is equal to F net divided by mass, which in this case is equal to 0 because the net force is 0. Divided by 62 kilograms gives us 0 acceleration. Of course, there are forces acting on this person. The 620 newtons pulling him down, and the 620 holding him back. But the net force is 0, and it's the net force that we need to put into the equation. And this links in with what we just looked at in the recap. The idea that balanced forces means there is 0 acceleration, and that's because there is no net force. If we change this to an unbalanced force example, let's say his parachute breaks, all of a sudden his drag force is only 20 newtons instead of 620. That means our net force is now 620 minus 20, which is 600 newtons down. So there is a net force acting in this case. If we use the same equation to calculate the acceleration, in this case it's 600 divided by 62, which gives an acceleration of 9.7 meters per second down. Bit of a problem for the young skydiver. And again, this links in with our recap, the idea that when there are unbalanced forces, there will be an acceleration. So this guy is going to start speeding up. He's going to fall faster and faster. Now we're going to look at some examples back with our fire truck again. And the first one is we're going to try and find the mass. So let's say there's a force of 240 newtons pushing on this truck, and it accelerates at 0.01 meters per second. We're trying to find the acceleration, use our triangle. We're trying to find the mass, use our triangle. F net divided by acceleration. Substitute in the values, 240 newtons divided by 0.01 gives us a mass of 24,000 kilograms for the fire truck. If we change the force, we could then find out the acceleration because we know the mass now. So let's say there's 4 lots of 240 newtons. So that would mean that the total net force now is equal to 4 lots of 240 or 960 newtons. If we use our equation now to find the acceleration, F net divided by mass, 960 divided by the 24,000 from the previous question, gives us an acceleration of 0.04 meters per second. And we see here that as we have 4 times the amount of force, we also have 4 times the acceleration. The two are directly related. Final question, if we want to find the force acting on this fire truck, how hard are the firefighters going to have to push it to accelerate it at 1.2 meters per second if there is a drag or a friction force of 500 newtons acting? So we cover up our F net, we're trying to find the force. We see that it is equal to the mass times the acceleration. Substitute those in, 24,000 kilograms multiplied by the 1.2 meters per second we're after, and we get a net force of 28,800 newtons. Is that how hard the firefighters have to push? Well, no, they actually have to push harder than that. They need to get the 28,800 newtons, plus they have to overcome the 500 newton drag force. Therefore, they need to push 29,300 newtons in total. So be careful when you're answering these questions. The equation will give you the net force. You have to take into consideration any other forces that are acting as well. So now you know how to calculate net force using the equation, and also how to rearrange that equation to find both mass and acceleration.